being able to attend CppCon in person lets you interact with the presenters and to really get to experience the character of the presentations and to engage more with the subject matter than just reviewing it online after the fact.
I think we're ready to go. Hello. So, my name is Mark Williamson. I'm from Undo. We do time travel debugging, and we do now AI, agentic debugging as well. And so you may have seen us in Daisy's excellent keynote. If you haven't, we'll be recapping some of that. If you have, you will have noticed that I chickened out in the keynote and used a video of our tech doing the right thing, because AI demos are always a little bit scary. Today, it is without a safety net. So everything we're going to do today is going to be live, hopefully. We'll see what happens. And we're also aiming for it to be interactive. So I'm going to do a bit of intro now. Then Daisy's going to come and join me, and we are going to experiment and see what we can get the system to do. So, first of all, though, I'd like to talk a little bit about time travel debugging. And it starts with this: what do programmers do all day? My view is mostly this, at least when they're doing technical work and not in meetings. So you write the code, hooray, that's, 10, 20% of your technical work, and then you try and figure out why the code doesn't work, and that's the rest of it, approximately. So when I say debugging, at least, I mean solving, actual crashes in the code you've just written or code others have written. But it can also be, it didn't crash, but it didn't work quite right. Or it did work, and I don't understand why. All of these things, or even just somebody else wrote the code, I want to know how it works. All of that, as far as I'm concerned, is this process of going crazy, grappling around the source code, running a debugger when you can, getting logs out when you can, trying to piece together the jigsaw. Now, I have some thoughts on debugging in a coding agent currently. So we had a really nice panel session the other day about how you can use agentic AI to help with debugging. They are quite good at sifting through huge amounts of logs. They're quite good about reasoning about your code. They can make some automatic use of other tools like GDB, in fact. But a few months ago, when I started using agents to debug code, the first thing that happened was that it tried to recompile my code with some more printfs in so that it could trace through what happened. And the image that came into my mind was of some sort of futuristic Terminator trying to hunt a mammoth with like a sharpened stick or a bone or something. I went through quite a few iterations of getting Gemini to generate these images. Actually, side note, I was unhappy because all of the mammoths looked really placid, so I told it to make the mammoth scary now, so it looked more like a fair fight. Scary mammoth. Not quite what I had in mind, but I enjoyed it. But yeah, what we're trying to do at Undo is provide the power of time travel debugging to these agents so that they've got insight into the full state of the program at every point in time, so you can get kind of the ultimate context into your context window and enable them to be as smart as their potential allows. So, time travel. We could do a quick show of hands here. Have you heard of time travel debugging? Hooray! Have you seen time travel debugging? Hooray! So, that is one of the best ratios I've seen. I am going to show you a little demo, though, just to set the scene. Blah, 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 blah. Here we go. So, in fact, I'll exit this. We'll start again from the beginning, and you can see what's going on. And also, while I'm at it, I'm going to do a little bit of AIing as well. Okay.
Thank you.
Is that all right?
Perfect.
Wonderful. Let me check my other one. These both look all right. So, I am going to run this program which has a bug. I'm going to run it in 2 tabs for reasons that will become scarily apparent. So, What happens when we run this program is it iterates through a known buggy program. Apologies if you've seen this one before, but it's a really good example for this. It's done a couple of thousand iterations of some maths function that a naive programmer's written for us. And then it's exploded doing a little self-consistency test, and now it's unhappy. So the question for us is, why did this happen? As always. And debugging, I would argue, is always a backwards process. Unfortunately, the tools we have mostly work forwards, but in your head, you're having to model the backwards reasoning of how did we get there, what's my theory, okay, what's my earlier theory, until you get back to the root cause. So we are going to do a little race, and this is not fair because I've done this a lot of times, but it's also not fair because I'm not a computer. So we'll see what happens. What I'm going to do is pull in our explain extension, which provides integration between our time travel debugger and a coding agent. And it's going to try and debug while I try and debug. And we'll see who wins. No idea what's going to happen because I've never done this before. This was Daisy's suggestion just before the talk, so you are living on the bleeding edge already. Explain what has gone wrong in this program. And by the way, I'm going to say as well, please explain in the style of a traitorous grand vizier who is secretly plotting, oh, that's not plotting, plotting to replace me. And we're going to leave that thinking about this program, and I'll give it a head start, and then we're going to dive into my debugging as well. So off we go. So we've powered up an AI agent in the background, and we've now turned over control of our debugger to the agent. So here we go. That's now getting to the end of time where a crash happens. It's getting a backtrace, and it's starting to reason about how this happened. Now, I'm going to quickly nip to my other tab. And so we're at the end of time. We're in this nice TUI dashboard mode. I'm going to reverse finish, back up the stack. You can see on the right, we've got to the user's main function now. Quick check-in with this. It's got to the user's main function, and it's gasping theatrically. Behold the treachery, your magnificence. I'm going to go back here. Right, what's happened? Well, we know we crashed here because these two variables didn't match. So let's step backwards through this code. And if we look here, we are just going to be, can I center that? Maybe not. We're just after the return from this function. So what I'm going to do is step back into the function that returned the bad value, and there was a cache hit. So what we know now is that our calculation failed because an earlier update to this cache actually contains the wrong value. Let's see how the Grand Vizier is doing. Oh, it's got back to the same place, actually. That's nice. So, most exalted one, the plot has been revealed. Yes, cache element 90 contains poison. Now, what we do at this point, and what the AI is doing at this point, is work backwards in time to find out when the cache entry was updated. Because we don't know exactly what the bug is, but if there's some bad state in the program, we know the guy who wrote it is most likely to be somehow implicated. So here we are in this loop. See how the Grand Vizier is doing. The Grand Vizier is now in this loop as well, and he's looking at where the corruption was planted. So treachery runs deep. It's beaten me. So let's see what happens. We were close. The beautiful irony. So what's happened here is that our cache algorithm is updating actually a few adjacent entries, or trying to, whenever we ask for a square root. So obviously the programmer thought there'd be some kind of locality of reference here, which meant it was worth doing this. But there are a couple of cascading bugs. So, first one, it's iterating from number -1, which is naughty. You can't square root that. Also, when it calculates the square root, it's coming out as this. But the other thing that's happening is that the cache has been optimized to only fit 8-bit quantities in. So obviously there was some domain-specific knowledge there, but as soon as we get into these crazy big or negative values, all the wheels fall off. So what's actually happened is the process of doing the bad maths and putting it in the cache has also destroyed the information that we would have needed to understand that the bad maths has happened at all. It comes out looking like the square root of 255 is 0. So the only way we've been able to work this out, and the only way the Vizier has been able to work this out, is by working backwards in time until we get to the point of the original corruption, the root cause of your program's downfall. Perhaps if one were to use larger data types for the cache, this unfortunate accident could be prevented. So, that's the basic premise. It's time travel debugging and agentic debugging all in one demo. I'm going to return to time travel. So, our premise here, as I've said, is that we are providing the ultimate context to the coding agent so it can be as smart as possible. And of course, if you combine time travel with agentic behaviors, you get something very effective. Now, we're going to dive into some more examples in a minute. I can't remember what else is on my slides. This is a really good reference, by the way. If you don't get it, sorry, it's a deep cut. It's one of the less popular Star Trek films. It's time now, I think, to dive into some bigger examples. So what I'd like to do is invite Daisy up to the podium, and together we're going to play with some prompting. We're going to try and replicate the examples you've already seen of the keynote, and we'll see how far we can get.
And hopefully have people ask questions of the debugger once we're moving, right? Like,
absolutely, yeah.
Ask their own
So
questions.
it'd be really nice for this to get interactive. Daisy, I mean, I don't think you need introduction, but probably a little intro from you is useful.
I'm the girl who's been talking about how great AI is this whole time. I don't know.
Yeah, that's fair.
I work on Cloud Code, and yeah, my keynote's online if you missed it.
Awesome. So, what I'm going to do first, I think, Daisy, what I'm going to do first is I'm going to start with the CPython.
Yeah. Oh, the CPython demo. Okay.
Yeah.
This is the hardest one.
Yes, it's the hardest one, and I want to give it a while to do its magical work. So,
This is a real bug that
Yes.
took like the Python community a month.
it's a couple of weeks, I think.
A couple of weeks? Okay.
Still. Yeah,
Yeah.
now, to be fair to them, like, I'm really pleased because it took them a couple of weeks because it makes it sound really cool. I'm sure they have day drops, but they are also experts in Python.
Yeah. And this is also a pretty dumb mistake.
This is a bit of a mind-bending. So this isn't PyCon, but this is a nice bit of code because it looks very small and harmless. And then the more you look at it, the more your head hurts. So there's a couple of things going on here because of how Python's dynamic. There's a class called base node, and then we've got a subclass called node. The magic that's happening here, I will say, I'm not going to try and explain it fully because I don't think I'm capable, but sometimes when we're talking about this next field in this code, it is a class level variable. Sometimes it's an instance level variable. There is no clue from the structure of the code which it's going to be, so you have to figure it out from the runtime semantics. And all we're doing here is making a node, making another node, and then exiting the program. And if you do that, almost certainly, if you do this on your own Python install, this will happen. So the question is, why?
And to be clear, this is debugging C code
Yeah,
because Python is implemented in C. So this is a bug with Python itself.
exactly. So there is no reason that you should be able to write Python code and get a segfault out, unless you're doing something weird with C types or something. Like this is expressible in Python. It should at worst give you a weird exception. What I'm going to do, I'm going to clear that off the screen, and we're going to start this process again. I'm going to run Claude code against a recording that we made with undo earlier of this bug reproducing. And to make it harder for Claude, I've not switched on the Python debug build features. So actually, you can make it a bit easier by doing -- with PyDebug, and then it will have assertions on about internal state, etc., and it won't quite get to the segfault. But what we saw in the release code was the segfault. So we'll run with that.
Sorry, are you running an optimized CPython, or are you running CPython with debug symbols?
I'm running. It is a standard, I believe, release of CPython. Does have debug symbols, but it's not been compiled with super low optimization. It's not a fully optimized build, though, actually.
But it's a released CPython. You didn't custom compile your own CPython.
So basically, what I did was I typed make.
Okay.
So it's whatever that default build does. It's not at the level of a full debug build. I think they offer a build with higher optimizations. That might work here too. I just haven't tried.
Cool.
But it does have inlined things and all of the nastiness.
There's all sorts of nastiness in this, and it doesn't have the internal checking you get with the PyDebug option on configure. So it's not going to...
It's not like the sort of stripped binary that you send.
We still have debug symbols. I mean, you can have a strip binary and you reunite it with its debug symbols. So that's still an option if you're debugging something that's been released. But yeah.
I am curious how well it would do without debug symbols.
I know. I actually, I kind of suspect better than you'd think.
I kind of do too.
Yeah.
It seems to be good at these things.
So it's quite a big prompt on the screen. But basically, I think there's a couple of things worth pointing out here. So last night, I used Claude Code to generate some instructions using its subagent feature. And I've put one set of instructions into undo-debugger.md, and that's just giving it some more advice about how to be a really good user of the debug tools.
It's like your Claude.md, but for your tool.
Yeah, exactly. But the other thing that I did is I created a named subagent in Claude called the Agent Bug Diagnosis Validator. And its job is to be an adversarial agent that will check the diagnosis of the main agent using access to all the same reasoning, undo tools, source code that the main agent has, and tell it if it's done a good job or if it needs to try harder. What I'm going to do is set it off on its way, and we will see how far it gets during the rest of the session. My hope is that without any interaction, it's going to root cause this. If it doesn't, we'll see what we have to poke in order to get it there. Right.
And you did tell it that this is valid Python, so it should, because at first it was just saying this is really dumb Python.
Yeah, exactly. I mean, I have a lot of sympathy with, I often found the default response was, you've written something bad, don't do that, which is true. But
And is probably the right answer unless you're actually a core Python developer, right?
yeah, indeed. So, shall we dig into some other...
You want to do the
demo?
Doom demo
I reckon
next?
Doom is good.
So the other agents that you run as Adversarial, it's just like literally an MCP tool that calls like Claude, like WebAdge.
No, this is built into Claude Code. We have sub-agents functionality. It actually came out of our hackathon week in June. And you can set up custom sub-agents with their own kind of system prompt that the main agent knows how to invoke. So these are not, you don't invoke the sub-agent yourself. And in fact, if Mark weren't being super careful for this demo, you don't even have to mention the name of the agent. The agent contains a description of what Claude is supposed to use it for. And it's pretty good. We're still tweaking the prompting, but would have been interesting to not even mention the agent and see what happens.
Can we see the sub-agent's prompt?
Yeah, I'll try and bring it up later. So, I've let Claude...
You have a tool use?
Yeah, I've let Claude stop on tool use so I can say a few words about each one, and then I'll just tell it to not ask again. So the first thing it's done is called a tool we provide. By the way, this is from a prototype of our future Undo AI product, so it's a bit raw, but it's also more powerful. What we're doing here is we're giving it the ability to re-query the recording that had the bug to find out what functions ran. So it's effectively function level coverage, but it's being analyzed dynamically on an already existing run of the program. What that's going to do is give it a hint where to start its investigation. So it's free to look at the names of all the functions, go look them up in the source code, read the doc strings if it feels like, think about what it knows about the nature of the problem, and investigate from any of these as it sees fit.
What is this bug report.txt file?
That's an internal thing that we used to pass to an embedding. We had a vector database in this code, and we'd make an embedding of a bug report the user had supplied, and then we'd look it up in there to provide it some extra hints. That's not active at the moment, so bugreport.txt is really not doing much. The one that's sitting on the disk there is just one that Claude generated earlier in order to call this tool. Let's go Doom. So, if you're at the keynote, you will have seen something like this. I played through a session of Doom, and I recorded it with undo, and now I've loaded it into the debugger. So, Let me see. Yes, I've set up all my state. So just to prove that we've captured the entire...
Oh, is this the Python or?
Yes, it's all good.
Okay.
Just to prove that we've captured the entire recording, I'm going to quickly replay through. What we've done here is we've set a breakpoint on the frame rendering routine in Doom, and we're having it dump out the frame buffer every time that's hit. You can see in the middle, I had a panic when I saw an enemy, accidentally brought the map up, and couldn't figure out how to get out for a while. So this is a complete playthrough of Doom. The example that we showed on the screen in the keynote was me asking a high-level semantic question about the behavior of the program. So shall I just go for that?
Yeah, let's do that. We'll do just really quickly the one that we did in the actual keynote, and then we're going to try a couple more, and then we'll actually see if anyone in the audience wants to try, has something they want to ask.
So, when was the second zombie killed during this playthrough? What we're going to see on the top right in the frame viewer is where the agent is currently poking about in history. So every time it navigates through the history of this recorded playthrough, we'll see the frame viewer update, and we'll be able to see what was on the screen at that time.
Question.
Yes.
A lot of you lost in in topicals. Are we now using Claude from inside UDP?
Exactly.
Claude inside.
Yes. So the question was, are we using Claude inside UDP? And it's yes. So what happens?
UDP inside Claude.
So the other one is using Undo's AI tools inside Claude. This one is using Claude as a kind of back-end provider of AI.
It's a Claude sandwich, right? Because you have the Claude that you're running has access to the undo session that you're running, and it's calling out to it. This all works through or will, by the time you release it, work through the Claude SDK, Claude Code SDK.
Yep, that's the plan.
Which, yeah.
Daisy, do you have a thought about this?
Oh, no.
I think I've spent a lot of our company money today.
Oh, no. I would to try again.
Yeah, let's try again.
This is gonna be a really interesting. No, I mean, this is the vast majority of the problems we have at Anthropic is.
So actually, just while we're there, is this my fault for using my key too much today, or is it the other end is busy?
Usually it's going to be the other end is busy. I don't know are you on, yeah, well, we can talk about it offline.
Yeah.
But, oh no, this could be a problem.
Has the other one failed too? The other one you're running, is that failed too?
Oh, you know what? That might be too.
Let's go have a look.
Try again.
Yeah, actually, we'll try this again as well. There's no harm in that.
Ask him what's happening.
Can we?
No, so this is an API endpoint failure.
So while we are at, so this one's still live. So we're going to do the next tool here, which is the ability to get a backtrace with timestamps out of a recording. So that's giving it an overview of where was it when things went wrong, when the segfault happened, and a time base within the undo history that it can use to kind of branch out its exploration. So I'm hoping that since this has got a live connection, it's going to carry on.
You might have to switch to Sonnet.
If necessary, we'll switch it to Sonnet.
But no, it's done a tool call, so that means that it is not.
Yeah, that was good.
I noticed it was saying Opus, and you're talking about switching to Sonnet.
Yeah.
How well have you seen it behave on the different sized models?
That's a good question. So I'll talk about my experience. Oh, look. Something's come to life. All right, hold that thought. Opus is feeling better now, and the exploration has begun. So this is why I kept the frame viewer up. In terms of how it behaves, I think actually we've got some quite good results out of Sonnet for some of this stuff. For some of the harder things, I find Opus is useful. I think it's possible that a combination of the two would work well. I'd also love to get some summarization from Haiku in there, and you can make Haiku sub-agents as well. I think that's going to be useful for when we've got lots of output to sift through.
And, oh no.
We'll just keep starting.
Just say, yeah, I'm sorry.
That's all right.
We can, do you want to try switching to Sonnet and see?
I think we'll just leave this going for a bit longer. We'll see what it does.
Okay. Yeah.
Also, is there a ballpark for the token costs that like this Doom demo can considers?
I don't have one in my head at the moment. I think it's usually... I think we usually spend at most a few dollars, single-digit dollars on this one. When we do a really big thing like the CPython demo, it can spend a lot more of our money, but still less than it costs to pay engineers to solve these things, I think. Is that question at the back?
Yes, can you also ask Claude to find intervals for you, for example, like Claude, tell me when my player got stuck got lost in the lab and then he got out again. Can you also do that?
I don't see why not.
When the player got stuck and
So
got
when I
out?
got stuck in the map, right when I...
Oh, try and find the spot where the player... Oh, that's interesting.
Sounds challenging.
We haven't tried it.
I'm up for trying it.
Yeah?
The real question there is whether you have a data structure to even answer the question.
Yeah, and I don't know. So it would be an interesting experiment, I think.
Yeah?
Do you want to go?
Yeah, we can try it. We have another one open.
Yep. So we've got another one open. Now we are tempting fate slightly because Opus is already having a busy day. But
Do you have a way to switch to Sonnet in
not
line?
in explain, I'm afraid.
Not in explain, okay.
If necessary, I'll go edit the code. But let's get to the end of history in this one as well. You can see the other one is still working. I think we could just check in on the CPython thing because I really want to get that running. Are you set to stay above others? I'll keep this on top so we can keep looking at it. Right, so the next thing, sorry for the switching back and forth, is the function logging tool. So our tooling here provides effectively an after-the-fact log of what functions did in a recorded execution. And what the agent's going to use this for is to extract kind of the control flow of any function it's interested in. It can unify that with the source code if it wants, so it can understand what actually happened during the bug. And it'll go away and query this. It's basically a kind of query-oriented approach. So I'm going to leave that.
And that's because you can't fit the entirety of it into context.
Exactly, yeah. So it's kind of one of the fundamental principles of this is we've got huge amounts of information and we cannot overload the LLM with it. So instead...
And you have a to-do list here too.
Yes.
This is it is making its own to-do list because it's planned this out.
Yeah. Daisy, have I done anything to make that happen? Or does it just do it
Nope.
for sufficient...
It just does that for sufficiently complex tasks.
Brilliant.
We prompt it pretty heavily. We use up some tokens to get it to do that, but we've decided we think it's worth it.
Okay, and that's coming from the internal prompting that ships with
Yes.
Claude Code.
And we remind it forgets about its to-do list every now and then. And if there's like still to-do list items sitting around, we'll like jump in and remind it, be like, hey, you still have to-do list items. Maybe you should cross off your to-do list items before trying to do something else.
So effectively, your like Claude Code agent scaffolding is acting as a sort of, I don't know, supervisor nanny to the LLM.
Yeah. And this is, as you know, this is real engineering work in that you try something, it doesn't work, and you try something else and it does. And you're like, okay, this works a little bit better than this, and so we're going to ship this, right? Like, it's not the kind of engineering that we're used to in software engineering as much because we're not used to like, oh, this works slightly better than this and fails, 10% less. Like, that's not a test that you usually run, but it takes a lot of work and iteration.
So we've come to another tool use here, which I'm just going to talk through, and then we'll leave it to investigate on its own for a while. So the other tool that we've provided is the memory report tool. This uses the history of our recording to tell the LLM for all the pointers that are accessible immediately from the current function call, are they valid or not? If they're not, when were they freed? And if they're allocated later, I think it tells you when it's allocated later as well. So this is using knowledge of the memory allocator to provide some more hooks into the overall history so it knows when to spool backwards and forwards and drill down on things. So I'm going to tell it yes for that and don't ask me again. I think that's the full set of tools, so it'll probably just carry on now until it thinks it's finished.
Or until the API failures.
Or until the API fails. So keep going. And then in this other one, let's be brave and ask this. So, please, I always like to say please.
Yeah.
Do you find that, I don't know, I just like Claude.
I like to too, and we don't actually really know if that helps or not.
Just feels good.
It kind of, yeah. Yeah, it feels good.
So,
There is some data on that, and we really don't know.
the player got stuck in the map screen during this playthrough. Oh, you can't see it because I've got the frame viewer in the way. Please find the first moment that happened. No idea whether this is going to work or not. I don't know if there's the right code and structure in there, but we'll go see.
And also, like, stuck is something that requires an understanding of time, and that's one of the open problems in LLMs in general, is that we don't really understand why they don't understand time.
So, let's carry on.
Did you have to repeatedly customize your tooling as you iterated with AI, or did you already have these tools?
So, I've got some slides on it if we have time in a minute. Right. We've got somewhere with Doom session number 1. So I'll come back to your question, by the way. We've got to what looks like the first point in time when I killed the second zombie. That looks about right. It's early in the level. There's another zombie on the floor, so I think it's done it. What has it found? So it's found my time in game ticks, level time. It's made a bookmark for me so I can go and review later. And it's decided that... this is your favorite.
Pistol. Yeah, the empty possessed is my favorite because it like figures out that a possessed is a zombie. Like I don't know if there's any comments in the code that make it figure that out, or
I've seen Claude have varying opinions on this.
Oh, really?
It always thinks a possessed is a zombie. There's also a shotgun guy. Sometimes it decides that's a zombie. But I've seen it explain a bit more, and it explicitly has said that it considers former humans to be zombies. So it's worked out former humans, and it's understood what the former humans are in the game's monsters. And sometimes when I do this, you'll see it stop and go, oh wait, that one's an imp, I won't count that. So it does know. Oh, it's got, cause of death, player's kill count, location within the game.
And if you knew that there was an issue with we were going to try and prompt it to give us the address of the zombie.
Oh yeah, let's ask it that. What is the memory address of the zombie? I'm not even going to tell it I mean the second one.
Let's see. Yeah, let's see what happens.
While we're waiting for that, see what's happening on the other one.
So if you've ever used Claude Code, there's a little spinner at the bottom that uses the gerund form of verbs that are randomly chosen based on what's going on. And they did a kind of riff on that by having a list of references to time travel movies. Is that right?
It's all time travel movies, so that's Star Trek, I think, 4, the Humpback Whale one. Basically, it's really a list of time travel references I've personally found amusing at the moment. And I keep putting it into pull requests.
Oh my gosh.
Improving it.
It looks like it's found the
It's been at the map before while we've been talking. So
okay.
I'm interested to see. Let's just have a look at this though. So it found the memory address of the second zombie killed. It's remembered it was the second one. It's got us a mobj t. I guess.
Map object.
I guess so. Do you know that for sure? Because sometimes I think it's movable object, sometimes I think it's monster object.
It says map object.
Well, I'll believe Claude. I think it's more of an expert in this than me. So I guess, if I cast this to a mobj t, we should see.
Yeah, there you
That
go.
looks about right. By the way, my original plan for all of these demos, way before we were even doing agentic debugging, was maybe I can step in and find the mind state, like the AI of the individual monsters. What I found, though, was that in Doom, there's not a lot of it. And I decided it wasn't going to make a good demo. Maybe when we move up to Quake.
Yeah.
So let's see how Doom...
But this is something you would do in a regular debugging session, is that you know the problem is with the second zombie, and you want to look at, so you're mixing user level debugging with agentic debugging.
Exactly, yeah.
And the agentic part is they're doing the boring part of like actually finding the thing, and then you're doing the thinking part of like, what's wrong with this?
Exactly. So this is actually doing quite a lot of interesting stuff. you can see it's found the map screen a couple of times, but I think it's probably incidental. It does seem to it believes it's found this automap active state, and it's searching around for that. So we'll see, but actually this is looking promising.
This is the developing the map.
Yeah, this is the when did I get stuck in the map.
And we are at level 0 with respect to prompting here, right? This is explain and then like just the question directly.
Yeah, so it's consciously we're giving it quite a difficult job here, I think.
And this is like much more of a like, what would you do when you're first working with the code base?
Yeah.
More than like, what would you do when you've been working with the code base for 6 months? You'd ask very specifically, like, when did the map hit the auto map active state? Yada, 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 right?
Exactly.
So it's kind of a good demo, but kind of like less powerful than it potentially could
Exactly.
be.
Well, actually, another thing that's worth saying particularly for Doom, is that I haven't got a Claude.md. So normally I'd go into Claude, do /init, and it would summarize the architecture for future sessions. Haven't done that here. I did for CPython. I don't actually think it needs it, but I did it anyway.
I do think. Oh, go ahead.
Does it have access to the frame buffer?
Pardon?
Does it have access to the frame buffer?
The-
Is it capable of
So
looking at the image? I
technically,
know it doesn't do OCR because Daisy covered that in the past.
So technically, it could dump out the frame buffer as a data structure and look at the numbers. I haven't seen it do it. I haven't encouraged it to do it, but there is simply a big array.
So if it wants, it can.
Yeah, if it wants, it can.
And you could give it a tool. You haven't, but you could give it a tool to actually turn the frame buffer into a PNG and then load it as a multimodal token stream.
Yep.
And I do that with my slides, by the way. Like the slides that I show, I have a tool involved in that when I say, Claude, make the slide look better, it goes and it will take a picture and then it'll change things and it'll take a picture.
That's so cool.
Yeah, it's a pretty common workflow, especially on people who do front-end development, which is like mostly not people here. But
So actually, whilst this is running, I saw somebody comment on Hacker News that agentic coding isn't yet ready to say make Facebook for dogs. So I made Facebook for dogs in Claude Code, and it ate my entire afternoon. It was absolutely fascinating. And the freakiest moment I had was when I said, the thing isn't rendering properly here.
yeah,
And it said, can I see it? And I took a screenshot and I gave it to it. And he went, oh, yeah, I see what you mean. Oh.
that's awesome.
So, it thinks it's found the moment. It's found the automap activated bookmark and the automap deactivated bookmark. So it's done a bit more than we asked for. What I'm going to do is just step slightly forward in the code and see if it...
Wait, it says it did not find any evidence of the player being stuck.
No.
It's only a question of semantics of what's stuck.
Yeah.
Because like you managed to get in and out.
Yes.
So it is stuck.
But it remained active for about 12 seconds, and I think it's characterizing that as stuck.
Yeah, I think that's just fair enough, actually. So I kind of rate this. It sounds about right. The only thing you'll... Oh, yeah, okay. So it does seem to have found... Possibly it's got them the wrong way round, which is interesting.
I think it's the screen update is one bit behind. But if you put a... Do you know what I mean?
Yes, you're right. So there's a... Can you remember what, Greg, as I've got you?
Capital D underscore display.
Yes. Yep. Greg's right. And now it's gone into my conditional breakpoint commands. But yeah,
That was pretty cool.
that was pretty cool. So yes, it can find when I got stuck in there. And very generously, it thinks I didn't get stuck, even though I clearly did. And I had a bit of a panic.
You also say please.
Yeah, no, that's true, actually. This is kind of paying it back. Let's have a check on CPython. Oh, right.
Did it get it?
Well, so I'm just going to scroll back and we'll review what it did. So it started way up here with my prompt. It's gone through, it's found which functions might be implicated, because it doesn't need to look at any which didn't run. It has got a backtrace at the end of time to find out what was going on at the moment of the crash and when all of those frames became active. Then it's gone backwards, querying out function logs. And you notice sometimes it will query out a full log. Sometimes it actually specifies a sub-range of history within the recording. So that means that Claude's decided something weird happened. Like one of the tools gave away something. And it starts to poke around there. I've seen it do reasonably intelligent things actually here. So
You cannot generate log for this function. This is probably related to being compatible with optimizations.
Well, actually, what I'm finding interesting here is it looks like, I can't see the function name because of Doom. Yeah, there's a couple of different functions. This one might have been inlined, I think. But you can also see it's playing around with different BB counts, which is our internal timestamp, to find out where something happened. So, by the way, Daisy, something that I found while I was doing this was I told Claude Code to think hard
Yes.
while it was solving this. And
Did you
then
say
I
think
started
hard or
saying
think
this.
harder?
I think I said think hard right at the start.
Okay.
I think there's a bit of a trick there.
Yes. Think hard is, I think this is documented publicly. Think hard is 16,000 tokens of extended thinking, and think harder is 32,000. Like we are, like I keep saying, we're in the infancy of tooling here. The way to turn on extended thinking in Claude Code is to put specific phrases. You can also say ultra think as one word. You put specific phrases in your prompts. We mechanically parse those out with a regex, and we turn it on if it's there.
Characterize the time implication?
The what?
The time, and it doesn't take longer.
Depends on how human in the loop you want to be. It takes, I don't know, what do you think? You've probably used it some. I'm very rarely using Claude with human in the loop. I walk away and go get lunch.
I find to be honest, I find it varies depending on the task. Sometimes I want to be in the loop to see if it's gone off track. Sometimes if I can set it up with a nice self-feedback loop. I guess though, my sense is that these extra thinking steps here, for instance, are taking a few seconds longer.
Yeah, a few
because I told it
seconds.
to think very hard. Ultra think is my favorite. I think there's a mega think and an ultra think, which I like.
Yes, and I think mega think is less than ultra think or something
Yeah, that's
like
right.
that.
It slightly disappoints me it's not SI units. I'd love to do a gigathink.
I will put in the what? Why not? Yeah, so I do. But tokens aren't free. But they are for me. We're hiring. You can, if you really want to always do it, there is I think documented in our documentation, there is an environment variable you can set that is max thinking tokens, I think, separated by underscores. And that will, I think the most you can do is 32,000, but max thinking tokens will just turn on thinking all the time. And I pretty much do that. That's in my ZSHRC,
So, now's the bit. I like doing these things because I have to do a quick rerun of a bug that I'm not always very familiar with and try and read the diagnosis of it to figure out what's gone on. So, spoiler, what we're ultimately looking for here is a mention of caching or the type cache because that's where the bug actually is. So see how far it's gone. So it's use after free bug, that's true. It's in the del method, that's true. Earliest invalid state, it reckons, happens here. We'll see what the validator agent thought about that. This looks good. It's definitely found clues. It's something to do with type specialization logic. That seems good. I don't think this has got all the way. So we'll see what the bug diagnosis validator told it. It might have spotted it.
It's confirmed my diagnosis and pointed out some important gaps.
Yeah. So now it's investigating the gaps identified to strengthen the diagnosis. So I'd say this is really new. I've only started doing this in the last couple of days because of Daisy's suggestions.
Aww.
But it's pretty cool. And I think this is what the future looks like, actually. This adversarial thing with agents is really useful. And yeah, go for it.
Can you see what the extra is saying?
Can we see it? So I can bring up the full logs. I don't think
Control R.
I don't think there's a nice way of just popping out what a sub-agent's done.
Not currently.
So
You just went into
Control R.
summarize mode. Now you're going into this is full mode, and this is going to be Oh yeah, here you go.
So let's find the start of it.
That is the agent's response, at least. You can see what the agent's responded with. I don't think you can see everything that the agent did. Well, maybe you
I
can.
think you actually can. So you can see it's extracted some more logs. It's had a poke around in the source code of the reproducer, other logs.
Mark is also on a 1-month-old version of because
Sorry about that.
because his auto updater broke.
Yeah, but we're fixing it. Oh, I zoomed. I didn't know I could do that. Yeah, so let's see what it actually came out with. By the way, one of the things that I really enjoy is watching the little Claudes complement each other.
Yes.
Because they tell you that you're absolutely right, but also look, perfect.
Yeah, I told you the story of in the talk, I told the story of how it had, when it wanted to test it out, it had two Claudes talking about Pokemon to each other.
Oh, that's awesome.
That was back in March. That was back in March when I did this the first time. I did this again recently, and they were talking about the nature of consciousness. So that was a little scary. That was August.
Why does it say I'm always right? Or that was absolutely, why did it do that? And how do I tell it to stop?
We have a current, fairly significant known bug with sycophancy that we are working on addressing. We have an entire personality team of some of the best people in the world for that, and they're working very hard on it. Specifically for Claude personality, yeah. 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 It does occasionally, but it shouldn't be so, yeah. The other thing you can do is it gets more and more excited that it has actually found the right answer. So if you give it a stop hook that will actually like check whether or not it has the right answer, and like tell it it's wrong, and it keeps going, so I had it making tmux sessions at one point to try to validate certain things, and it kept naming the tmux sessions like increasingly unhinged things, like verified in all caps, final success,
Yes.
success at last.
I actually saw this last night. I had 2 sub-agents. I've stopped doing it because it's slow because they have to start from scratch. But I had a debug agent and sub-agent and the validator sub-agent. And what I was seeing was the debug agent would say like, review my diagnosis. And then it said, detailed review of my diagnosis. And then it said, final review of diagnosis. It was, you could see them sort of amping up and like setting the expectation for, you're really going to finish soon.
Which, to be clear, is something we characterize as a bug. Like, we do think this is a bug. We need to get better at it. And we will, but.
So, I don't think it's quite got to the root cause yet. It's really close. What we're looking for is that mention of the type cache. By the way, what was actually happening in Python, what we're looking for it to find, is that it's got a whole reference counting situation going on. That's fine. It's got a cycle detector. That's fine. There is also this thing called the type cache, I think, or the type attribute cache. And that is allowed to borrow references without actually incrementing the reference count. And there's this particular corner case that the code provokes in which there's still a reference in that cache, and we didn't clear out the cache when the object was freed. So we're looking for it to get there. While we're doing that, more do.
Yeah, we're due. Let's do it. Try it.
What should we try this time?
Does anyone have a suggestion?
If it has access to if you have the tool for the PNG, can you ask it to make the image, I don't know, redder or whiter? Maybe you need the opposite tool of turning its PNG back into a.
I don't think it can actually edit. Do you have ways to edit the traces?
Not now, no.
Okay.
So fundamentally, the time travel trace is deterministic. That's kind of the value. So there's no way for it to make a long-term alteration for it.
Could it write out a new file?
So I have done that. I don't think I'm going to dare to try it now. But on the CPython example, I have actually had it, with a little bit of poking from me, do several iterations of trying to fix the bug, record it, diagnose why it's fixed didn't work, try to fix the bug again, record it, and then ultimately actually came up with a working fix, which I believe was actually sane. And then it recorded it and analysed it to make sure the fix was invoked. That was cool.
Well, I mean, like, the .undo file is a file, so
Yeah.
I can't edit it in line.
Can't
Oh.
edit that. No,
It's a binary file.
It's a binary file. Claude knows nothing about what's in there. But it can always make a new one. It can just record the application again. So if it makes a change, or if it wants to see if it behaves the same each time, basically just can.
I mean, I find it seems like Claude would be able to read and try and puzzle out the binary format.
It could. It just would have a tough day at the office to do it, I think.
That seems like a stretch, even
Um,
for a
Yeah.
true believer. It's a text-based model, right? And there's no text in there.
It's a binary file, and it doesn't actually contain the full state of the application that was recorded, because one of the things that undo does is recompute states on demand. So actually, to be honest, editing the files almost certainly will cause a crash. They're not really an editable artifact in themselves, except through our tooling. And even then it's limited.
Probably could if you gave it access to the undo source code.
Yeah.
But given that you have a product you're trying to sell, I don't think you're going to put the undo source code up on a live demo.
Probably not, no. Sometimes I'll show a bit of it, but shh, don't tell Greg.
Is that the first level of Doom?
I believe so, yes. It's the shareware Doom level.
Okay.
So I haven't expensed Doom on the company yet. I'm counting myself lucky that I can play it quite so much as part of my job.
Ask when the player lost the ability to get the chainsaw.
Okay. Yes, so when did the player lose the ability to get the chainsaw?
Because it goes away at some point, is that?
In the first level of Doom, as you spawn, if you immediately run backwards, you will get a chainsaw. If you do not immediately run backwards, a gate will close, and you will lose access to the chainsaw.
That is so good. So,
This is a really, I will be surprised.
yep, we'll see what that does. I'm going to so there's one thing that I would like to show on the other one while we're doing this. So let me just see what we've got in the timeline at the moment. So the timeline is showing us all of the bookmarks that have been created. I actually think I'm going to clear those ones out because they're a distraction. So what I'm going to do here is first of all explain.
Are you going to do the table thing?
So I'm going to do the two-step. So
Okay.
do you think that's good?
Yeah, it's a great idea. I think that's a great demo.
Find when each enemy was killed during this playthrough and create bookmarks. Now, this is, I guess, you said we were at prompting level 0 earlier. This
Yeah.
is maybe prompting level 0.5.
Yes. Yeah. This is like multi-step. Like we're trying to pull in a good set of context for the question we plan to ask.
Yeah, so the question we're planning to ask on this one is to get it to tabulate all of the times that a zombie took damage and how much damage, so we get a complete timeline of the game. But to prep it for that, it's helpful to get it to think about each time the zombies got killed, so it knows that it has jumping off points. So this is a combination, I guess, of priming the LLM state and also priming the state in the tool, so it will be able to navigate better.
By the way, going way back to the Opus failures, I think that we said that you're using the Claude Code SDK.
Yep.
Not quite using the Claude Code SDK yet, because they were working on this before we released the SDK. Now, before you release this as a real product, probably will migrate. That will help with the exponential backup of retries and things like that we all do to make this happen less often. Which you noticed was not happening as often in the Claude Code session.
Yeah, yes, exactly.
So that logic should help, hopefully.
Brilliant.
Which frame is which query?
So, the bottom frame is looking for all the kills at the moment. The top frame is looking for the chainsaw. So let's keep an eye on. Let's just go back across to the terminal on that and see what it's doing. So it's looking for chainsaw-related map object interactions. Okay. So it looks like it's having sensible thoughts about this. Kind of looks like it's looking for me getting the chainsaw rather than not, but...
Is it reinterpreted the question?
It may have.
When we search for any that are in this level.
But we'll see. I think we should give it a go because it is surprising and spooky what it manages to come up with.
And to be clear, you kind of have extended thinking on.
Oh yes, we should talk about that.
There's a really interesting thing going on here, right?
Yeah, so I haven't, in this instance, I haven't told it that it should think extra or think hard.
Right, so there's no actual, like, of the trained in thinking scratch pads that we use in the API. Oh.
Oh. Well,
Where a chainsaw exists in a secret area. Wow.
I think now,
The player found 0 of 3 secrets in the level?
yeah, so I think to be fair, it can find some of this from looking at the source code, right? What it hasn't done is found the moment that you asked for. We can prompt it some more and see if it will.
Yeah.
But it's definitely verified that we didn't get it and that we didn't find any secret stuff because I'm not very good at this. So,
I mean, that's a really hard thing to see. An object went in between the player and the...
I know.
Is it not possible that it got, from a page that talked about where to get that secret chainsaw in that level?
probably did.
No, this is not a... This can't... You don't have web query on,
No.
right?
Well, I don't think so. So,
Yeah, it could be in the
might-
training data.
So it might be from training data, might be from snooping the source, but what it has been able to do is verify that I didn't do that. And you can see that it's checked the data structure, so I believe if I had found the chainsaw, it would have told me I was wrong. I've asked it to try a little bit harder, and we'll see what happens.
But you were talking about thinking.
Yes, sorry, we were talking about thinking. So, yes, we're not using conventional extended thinking here, but what you can see coming up is there's this thoughts field on every call to the debugger. And this was...
Yeah, we talked about this one of our first meetings, right? Is that when you specify a tool format, you have to give it a JSON schema. And what Mark and his team did was to give make one of those fields be, originally it was called hypothesis, is that right?
Yeah. So internally it still is. It's just called thoughts.
Oh, okay. Yeah, so it has to fill in a hypothesis field, and then you just don't do anything with it other than display it.
Exactly, yes. So we are basically lying to the LLM, effectively, and we're saying this tool will only work if you tell it what you're thinking about when you call it. Then we print it out to the user and throw it in the bin. We don't use it, but
Because how would
it's
you
had
use
to
it?
think harder. And that actually, I think it makes it smarter.
Yeah. Did you actually do any like quantitative tests on whether that helped, or?
Not yet, no. I think that's something to dig into.
It's kind of hard to test quantitatively, but
Yep.
yeah.
So technically, we are at time. If we can bear to go a couple of minutes over, then I think we could take any final questions, and hopefully we'll see what these all come out with.
How's CPython doing?
Let's see how CPython's doing. So, type specialization systems using cache pointers without verifying they're still valid. Type method cache is not immediately invalidated when objects freed. Yep.
This is the actual bug.
Look a bit harder, but yeah, that's where it caused it. So we've done it in an hour whilst doing other stuff. It took a couple of weeks in real elapsed time for the Python developers to do it, and they actually know how this stuff works. I'm reasonably pleased with that.
And this is like level 1 or even level 1.5, right?
Yeah.
That was a very extensive prompt, something much more like what a developer of CPython would actually write.
Yep.
And so it's not just like, why is this failing?
Yep. Although actually, I did put very little CPython specific information in there, which it's got the claw.md,
Okay.
and it's got my argumentation of here is the reproducer, and it must be valid Python, but I haven't pointed it hard, except for that one prompt you saw me write in where I said, why did it manage to reach that reference if it was at 0? Why was the object still reachable?
And there is you didn't do the cloud.md. It had it already, or?
I made it last night,
Oh, you made it.
but I just got Claude to make it. I didn't do anything tricky.
Can you ask what is the problem here, not what's the problem here, and fix it, right? For that sequence.
Yep. So I'd say in terms of prompting, that's probably a 2-step one. I'd like to automate the steps. I think that might be future work. But yeah, ideally, what you want this to do is to be able to drive itself. So iterate until you've found a root cause, then iterate until you've got a fix that works. Can run the whole Python test suite, and it can run the reproducer as well. And then tell me it's done. And I come back after lunch and we've got an answer.
Do you want to pull up that agent? We talked about the sub-agent file.
Oh, yes. sorry, we did promise we'd have a look at this sub-agent, so let's just do that now. It's longish, so if you want to see it in full, we will, you can grab us afterwards and we'll show you then.
And did you write this, or did Claude write it?
Claude wrote it. I think I edited a couple of things because I wanted it to be clear that it was supposed to use undo tools, not just whatever it felt like. So here we are. There's a description up the top. There's some information on what tools are allowed. And then you're our senior software engineering diagnostician with 15 plus years of experience in complex system debugging. So these are how it's meant to evaluate bugs. These are the criteria. These are the output structure that it returns to the main agent.
And how long was the prompt that you gave Claude to make this agent?
A few sentences.
Yeah.
Basically.
So Claude expands on it, makes an agent.
Yeah, it's really good at that.
We have an agent making agent.
Yes.
And you can, if you use Claude Code a lot, it's like /agent will default to allowing Claude to create it.
So, and whilst we're here, the other agent description that I got Claude to make, which I gave the main agent, is telling you're an expert debugger specializing in undo's time travel debugging technology. Way, I knew what that was, which was nice.
Yeah. From the pre-training data.
Yep. Provide clear explanations of the causal chain, be persistent and thorough, never stop at symptoms, always find the true root cause. I actually found Claude generated really good prompting about how to be persistent here, and how to kind of keep the agent working until it got to the real root cause. Never take the first answer as a given.
Probably because it has a lot of people complaining about Claude Code in its training data.
Here we are, look, persistence requirements. So it generated quite a bit on that, and actually that was helpful.
And you actually just gave this to the main agent.
Yeah, I just gave this to the main agent because I actually wanted I wanted the main context to be the core debugging work, and then a separate agent which doesn't have all that baggage to validate its answer.
And we have people that use networks of a dozen different agents calling each other, talking to each other. If you're setting this up in a real software engineering environment and have the time to do all this setup, then it can get quite complex.
The validation agent, is it also using UDB, or is
Yep.
it just looking at the text
Yep.
from the primary agent?
It's using UDB, which means the primary agent can say, I believe these things happened because I see these timestamps, and this is what happened at these timestamps, and the validator can then load it up and check that that is what happened and that that is the correct explanation.
So UDB itself is stateful in that, like,
Yeah.
you set them. Do you ever see the agents messing up each other's state? And thus
No.
getting confused?
No, so they're isolated for purposes of
Okay,
this.
they
So
just get an isolated UDB
Yeah.
instance.
And your MCP server is handling that, basically.
yeah, exactly. The MCP server is managing UDB sessions behind the scenes. So we haven't got, I don't think we've got much further on why couldn't we get the chainsaw. I might have a play with prompting later to see if I can, like, say, when would they have had to open the door or something, but it still seems...
Or like, are there any doors or obstructions that would explain this or something, you know?
And then, if we look in the other one, we are on the way through to tabulating all of the enemies, I think. I'm just going to stop that and say, please tabulate what you have so far so that we can all finish this session. We'll see if it works. This is a object lesson in why I should update.
Oh,
SDK,
yes.
I think.
Oh, whoa. Yeah, we fixed this in like 1.0.88 or something.
Yeah, sorry about that.
That's, that was a quite nasty bug. TypeScript is not a great language. I don't have to convince you all of that, but I spend a lot of time trying to convince my team of this.
And so just for what it's worth, here we are. We've got a timeline of what happened. It's even actually put the map screen opening and shutting in, even though I deleted the bookmarks. Yes, question, sorry.
You said a timestamp. Is that like a instruction index in the appropriate thread, or is that the timestamp?
So there's two levels of timestamp here. One is the time offset within the undo recording, and we use our own units called BB counts for that, but they more or less add up to how much code has run by now. It is, the BB does stand for basic block. It's not quite the same basic block as you have in a compiler, but it's about the same level. The other thing that's going on though, so in explain, I've actually not let Claude see the timestamps because sometimes they're a distraction. So it doesn't have access to our timestamps, only bookmarks, but it's found that there's this game tick counter in Doom, And it knows how to convert game ticks to real-world seconds. So what it uses, actually, it uses the debugger to do the maths. Like it sends it, please multiply these two numbers together. And then it comes up with these nice little tables where it tells you how many seconds into my playthrough it was.
And you didn't tell it any of that?
I didn't tell it to do that. I didn't even tell it should use it as a calculator. It just sort of figured it out. And I let it carry on.
I think we've done some work to teach it that it's bad at math.
Okay.
Yeah. But yeah, these are the kinds of things we're changing slowly in models and in, like, it's real. Not that software engineering isn't also real engineering work, but it's like messy.
Yeah.
Like real software engineering is.
Yes. Real world,
yeah.
like fuzzy edges, awkward requirements.
Yeah. People think that the term prompt engineer is like a negative in some sense, and I think we're starting to come around to realize that that's actually valuable work that takes a lot of skill.
Really hard. Really hard.
Yeah, from someone who's done it.
Yes. So I'm going to say you guys have very generously stayed a bit longer for this, but I realise you've got other things to do and other talks to see. So I'll say thank you very much to Daisy. It's been brilliant. And thank you very much.
Thank you, Mark. This was amazing.